Hi, in this video we will learn about Taylor series. My name is Devashish and this is an Ed Sharpener production, and we keep posting videos about different education hacks and different education content. So of course today's topic is Taylor series. This is a very important topic, and we will go through what exactly Taylor series does, and we will look at some techniques in which you can express any function using Taylor series. So the agenda of this video is to learn to express any function in the form of Taylor series. Let me quickly tell you why at all we use Taylor series. So first you need to understand why we at all use functions, why we at all make use of this thing here. So we usually differentiate functions, we usually integrate functions, and then we deal with different complex systems to make engineering solutions. You get differential equations, right? Differential equations, and then you solve a mathematical model and you get a solution. This solution mostly suffices with the real practical world. But not all functions are differentiable, not all functions can be integrated. But we know that a function, if it can be expressed as a polynomial, right? You know what is a polynomial? Polynomial is the expression like this, right? An x to the power n plus n minus 1 x to the power n minus 1 and so on a naught. An example of a polynomial would be simply x cube plus 3x square minus 4x plus 5, right? So this is a polynomial. And what we know about polynomial is that polynomials can easily be integrated and polynomials can easily be differentiated. And if we are able to express a function as a polynomial, we can easily solve differential equations, which in turn let us solve complex engineering problems, and we get a very good practical solution to our engineering systems. So that's why we are actually learning Taylor series. So if this is clear, you must have already understood that all that Taylor series does is that it allows us to express any function f of x as a polynomial. So let us quickly see how we can find the Taylor series of a function. So Taylor was a great scientist and he said that any function f of x can be expressed as the sum of certain type of terms. So we can write f of x is equal to summation of certain general term, which I am going to write here. The nth derivative of f of x at point x is equal to a times x minus a to the power n divided by n factorial. And this n varies from 0 to n. So this is basically the Taylor series form. Many students get very confused when they look at this particular form. This is not a very difficult form, and we will see an example of how we can deal with this particular form. But first, what is this A? This A is basically the point about which the Taylor series is being designed. Let me tell you a bit about this point A. Please remember that Taylor series is basically the approximation, right? So we are just trying to approximate the function f of x using some polynomial. Of course, we cannot actually replicate the given function. We can only have the closest value at certain given point. Okay, so let us say we have the function f of x something like this. Let's say this is that function f of x. And now what I'm trying to do is I'm going to approximate a Taylor series for this function f of x. But it is very difficult for us to design a Taylor series for all the points. So what we do is we select certain point, like let's say this point here, and about that point, let's say this is that point x is equal to a, and about the closest values of point a, we try to approximate certain polynomial, and that polynomial is this, which is the nth degree polynomial, as you can see. So that graph would be something like this. But at x is equal to a, the function f of x and this blue graph, which is the polynomial, right, they match perfectly. And that's what we are trying to do. We are approximating a function f of x using a polynomial which is same, which gives the same values at about x is equal to a. So you often get to read such kind of questions where you need to design a Taylor series about certain point a, and that's what we are interested in. I hope you understood what this a is. And now we will take certain example where we will have some function f of x, and we will try to design a Taylor series about certain point a, and this point is often given to you because we know where we need to approximate our functions. Let us write down the general form of f of x again. So it is summation from n is equal to 0 to n itself of numerator is nth derivative of f of x at a, then you have x minus a to the power n divided by n factorial. Now let us say we have f of x as e to the power x, and we will approximate the Taylor series about a where a is equal to 0. The first step in finding the Taylor series of any function is to find some derivatives of the function, like first derivative, second derivative, third derivative, and so on. So what we'll do is we will try to find some derivatives. We know f of x is e to the x, so f dash of x is also e to the x, right? F double dash of x is also e to the x, and so on. So all the derivatives of f of x are e to the x. We need to find a derivative at a, and a is equal to 0. So what we are going to do is to put x is equal to 0. So all these derivatives are actually 1 because e to the 0 is 1. So one part is done. The next step is now to start putting the values of n for the general form and start writing the terms. So first let us put n is equal to 0. For n is equal to 0, the zeroth derivative of f of x is basically the function itself. So that's f of a, and f of a is 1. Okay. And then you have n is equal to 0. So x minus a to the power 0 is 1. 0 factorial is 1. So the first term with respect to n is equal to 0 is 1. Let us write the second term with respect to n is equal to 1. Now, if you put n is equal to 1, we have first derivative of f of x at a is equal to 0, and the value is 1. Then you have x minus a, and a is 0. So basically x to the power 1, which is x divided by 1 factorial. And so you have it as x. So this is with respect to n is equal to 1. Let us see the next term with respect to n is equal to 2. For n is equal to 2, again, you know the second derivative of f of x is e to the x, and at a is equal to 0 or x is equal to 0, you get 1. So again, this term is 1. Then x to the power 2 divided by 2 factorial. That's what you have. So this is with respect to n is equal to 2. And usually, after writing certain number of terms, you get to see a trend in the terms. And if you continue using the third derivative, you will find with respect to n is equal to 3, the next term is x cubed divided by 3 factorial. Next one is x to the 4 divided by 4 factorial, and so on. And this is how you can continue writing the Taylor series up to any number of. So this is how you can form the polynomial for e to the x depending upon the degree that you have. So basically I can write e to the x is equal to 1 plus x square divided by 2 factorial plus x cube divided by 3 factorial, and so on. I can continue writing it down up to infinity, and please note that if I write more number of terms, I am reaching to more accuracy with respect to the approximation. Usually you can also express this general form with the specific function that you have. So I can express this polynomial as e to the x is equal to summation of all such general terms, and the general term is x to the power n divided by n factorial, and then you have n varying from 0 to n, and this is the general form of the Taylor series of e to the x. I hope you understand. Please note a very important thing, that when A is 0, we say that the Taylor series is nothing but a Maclaurin series. Let us take one more example here. Now let us say f of x is equal to sine x. Again, we will express the general form first. So let us write down the general form just for the sake of simplicity. So the f of x is given by summation of terms from n is equal to 0 to n, and this general term is nth derivative at a x minus a to the power n divided by n factorial. And again, we will take the Taylor series about a is equal to 0, so we don't have to worry about the rest of the terms. So let us first find out first few derivatives of f of x at a is equal to 0. So f dash of x is basically cosine of x, and therefore f dash of 0 is going to be 1. Then we have f double dash of x is equal to minus sine x, and so f double dash of 0 is equal to 0, right? Then we have f triple dash of x is equal to minus cosine of x, and so f triple dash of 0 is equal to minus 1. Then we have fourth derivative of x is equal to sine x again, and this value at 0 is 0 again. And then the same cycle continues because we got the same thing, and then the values repeat for the fifth derivative. We could say fifth derivative at 0 is equal to 1. Then we have sixth derivative at 0 is equal to 0. The same values are going to repeat. The seventh derivative at 0 is going to be minus 1. The eighth derivative at 0 is going to be 0 again, and so on. Now we have few derivative values and we are done with this part. And now what we just have to do is to put n is equal to 0, then n is equal to 1, and so on, and to get the Taylor series. Let me just use another color here so that we can write Taylor series comfortably. Let us put n is equal to 0. What happens when n is 0? So we have f of a directly, so we don't have any derivative, and we want to find f of x at x is equal to a, right? A is equal to 0 and sine x would be sine 0, so this whole term would be 0. So we have no term 0 for n is equal to 0, right? Then we will write n is equal to 1. Let's see what happens for n is equal to 1. N is equal to 1 means f dash of a, and that is basically f dash of 0, so that is 1, and then we have x to the power 1 divided by 1, and therefore we have x divided by 1, which is x itself. Again, for n is equal to 2, let's see what happens for n is equal to 2. At n is equal to 2, the term that we get is f double dash of a, or f double dash of 0, and that is 0, so that term is 0 again, so we don't have to worry about it. Let's see what happens for n is equal to 3. For n is equal to 3, if you notice, you get f triple dash of 0, which is minus 1. So you have minus x cube by 3 factorial. If you check the trend, if you keep on going, you will see that the next term is again 0 for n is equal to 4. But for n is equal to 5, the term is not 0, and that is basically x to the power 5 divided by 5 factorial. Then you have 0 again, and you can continue the series. And if you just notice the non-zero terms, like these terms, right, you can write the Taylor series for the sine function as sine x is equal to x minus x cube over 3 factorial plus x to the power 5 over 5 factorial minus x to the power 7 over 7 factorial plus x to the 9 over 9 factorial, and so on. And this is how you have written down the Maclaurin series, because here a is equal to 0 for sine of x. I hope you understand. Please make sure that you also solve for the Maclaurin series of cosine x, and write that answer in the comment section so that I get to know that you have understood this topic really well. I would give you one more exercise where you just need to find out the Taylor series for 1 over 1 minus x, 1 over 1 plus x. And let us find out the Taylor series for e to the 2x. Just a hint, you write down the Taylor series for e to the x, which is like this: 1 plus x square over 2 factorial plus x cube over 3 factorial and so on. Then just replace x by 2x, right? So this is how you can actually manage to get different Taylor series if you know some basic Taylor series. You can also find out the Taylor series of sine 2x, sine x square, maybe cosine of x cube, and so on. Try to find all these Taylor series, try to express different kind of functions in Taylor series, and let me know in the comment section if you got them correct. We will finish up this video here, but we will come back with different more content on Taylor series because there is something called as error in Taylor series, and we will have one more video where I'll explain how to get different Taylor series like I just shown. So if you like this video, please give me a thumbs up, and please subscribe to the channel, because if you subscribe to the channel, it really encourages us and we will put more videos for you. Please let us know in the comment section your rest of the feedback, and I'll see you soon again. तब तक के लिए ज्ञान पीते रहिए.